Hello friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn cells in series. Before going into this topic, just to recall one formula. If it is series connection, the equivalent resistance R is equal to R1 plus R2 plus R3. You know that cell has one positive electrode and negative electrode, but battery can be made up of one or more cells. In a series connection, negative terminal of the first cell is connected to the positive terminal of the second cell. Again, negative terminal of the second cell is connected to the positive terminal of the third cell, and so on. This free positive terminal of the first cell and free negative terminal of the last cell become the terminal of the battery. Suppose I have n cells. Each cell has an EMF Xi and an internal resistance R. These cells are connected in series with the external resistance capital R. Then how do you calculate total EMF? The total EMF of the battery is N into Xi. Then total resistance in the circuit, that is equal to, here each cell has EMF Xi and internal resistance R. Totally we have n cells. So the total resistance in the circuit is n small r plus this capital R. This is for internal resistance, this is external resistance. Say this is my equation 1 and this is my equation 2. According to Ohm's law, we can write V is equal to I into R. I need I. Then how do you write? I is equal to V by R. Instead of V, you can substitute total EMF. Instead of R, we can substitute total resistance. What is total EMF here? N Xi. Then total resistance is NR plus capital R. Say this is my equation 3. Next we will discuss two cases. Case A, if small r, that is internal resistance, very much smaller than capital R. This is external resistance capital R. So just neglect small r in equation 3. So I is equal to N Xi by R, because we neglected this internal resistance small r. What is this Xi by R? Xi by R is nothing but I1. What is this I1? I1 is current due to single cell. Substitute here. So I is equal to N into I1. And what is this I? Current due to the battery. So what is your conclusion? Current due to the battery is N times current due to the single cell. Case B, here if small r is greater than capital R, just neglect capital R. Then how do you write equation 3? That is I is equal to, here you neglected this one. So N Xi divided by N into small r. Cancel this N, you can get Xi by R. What is Xi by R? Xi by R is nothing but I1. So according to case B, you can get I is equal to I1, which means current due to whole battery is equal to the current due to single cell. Hence, no advantage in connecting several cells. It is advantageous when the internal resistance small r is negligibly smaller than the external resistance. If it is series connection,
R should be less than capital R.